Close surgery happened. No scalpel touched the patient. Researchers moved a solid object through living tissue without a single incision. Every risk tied to cutting into a body, infection, blood loss, scarring, depends on that cut happening in the first place. On July 6, 2020, a team at the Center for Industrial and Medical Ultrasound at the University of Washington published results in the Proceedings of the National Academy of Sciences showing exactly that. And the tool they used was sound. Here is what acoustic levitation actually is. High-frequency sound waves, beyond anything the human ear detects, collide and create pressure zones. At specific points between those zones, the forces balance so precisely that physical matter stops falling. It hovers. No contact, no support, just sound holding an object in three-dimensional space. Researchers have done this with liquids, biological samples, and solid particles. This is not a trick, it is reproducible physics. The University of Washington's 2020 study did not levitate objects in a lab dish. They moved millimeter-sized solid objects inside a living organism from outside the body at ultrasound power levels safe for biological tissue. That is the detail worth sitting with. The manipulation happened through skin and tissue. No entry point, no instrument inserted. Sound, directed from outside, guided matter through a living body. Look, this did not come from nowhere. A perspective published in Nature Communications on June 16, 2022, Volume 13, Article 3459, traced acoustic medicine back to 350 BC, when Hippocrates listened to a patient's chest to detect fluid in the lungs. That was passive, observational. What the University of Washington demonstrated is the opposite. Sound that does not just detect, it acts. The same 2022 paper called Newly Developed Acoustic Technologies, a transformational role in biomedical applications, covering drug delivery, tissue engineering, and large-scale organoid manufacturing. The scientific community is not treating this as a fringe idea. There is one more piece that does not get enough attention. The University of Washington's work on ultrasonic levitation for micro-well plates was specifically aimed at bringing the precision of specialized surgical tools to general-use robots. Surgical robots today are extraordinary, but they are expensive and available only in well-resourced hospitals. If acoustic levitation can deliver that same precision through sound fields rather than physical instruments, the barrier drops. The precision moves from the hardware to the physics of the wave itself. That is not just a medical shift. It is a question of who gets access to precision medicine at all. No acoustic levitation procedure has replaced a scalpel in an operating room yet. The clinical chapter is still being written, but the foundational science is settled. Sound can suspend matter. Sound can move solid objects inside a living body without breaking the skin. The question is no longer whether it works. It is how precisely it can be controlled and how fast clinical translation can follow the physics. If this is the kind of story you want more of, subscribe. New episodes publish every Tuesday, Friday, and Sunday. Hippocrates pressed his ear to a patient's chest in 350 BC and called it medicine. In 2020, researchers in Seattle moved solid objects through living tissue using nothing but sound. The ear became the instrument,